Now we are going to solve 24th problem from APMT 1994. We want to calculate resistance between A and B. So imagine that current is entering from A and leaving the circuit from B. First solve boxes. First we are going to solve this box. In this 3 and 3 same current is flowing. So 3 and 3 6 and this 6 it is different. So this 6 and this 6 are in parallel. So 6 into 6 by 6 plus 6, 36 by 12, again it becomes 3. So now we can remove these 3 resistance with one 3 ohm resistance. It is 3. It is E. 3. It is D. It is A. It is 6. It is 3. It is C. It is 6. It is 3, it is B, similar case again. Now I have to solve this. This 3 and 3, it will become 6, and this 6 and this 6, it will become 3. So in this step, it will become 3. After that, similar case again, 3 and 3, 6, 6 and 6, 3. So finally you will get 1 3, 1 3 and 1 3. So 3 and 3 6 and this 6 is parallel with this 3. So finally we are getting 6 into 3 upon 6 plus 3. 18 by 9 means 2 ohms. So we are going with A option. Next, it is from 1995 AIPMT. 2 wires of the same material have same length, different cross section, joined in series. The resistance of thicker wire is 10 ohm. The total resistance of the combination is, see, one wire has resistance R1, first wire, thicker wire. Second is R2. Length is same. Area of cross section, if for first wire it is 3A, for second wire it is A. Means resistance of R1 should be 1/3 of R2. Thicker wire has 1/3 resistance, R1 by R2. What we are getting? 1 by 3. But they are saying resistance of thicker wire is 10, means they are saying R1 is 10. So R2 should be 10 into 3, 30. So in series, total 10 plus, they are joined in series. So total resistance should be 10 plus 30. 40 ohms. So we are going with A, 25th A. 26th. What will be the equivalent resistance between 2 points A and D? See, this is open circuit, so no use for this. This is again open circuit, no use of this. So how current will move? From this, I current is moving. It will move in 2 ways. One will come I1 from these two. I2 will come from this side. Joined, then combined I will move again in this. It means I in this circuit, I in this. So these 3 should be in series. First 10 ohm, I current is moving. Now we will solve this box. After A, I reached at P. it is Q. Between P and Q, what resistance is there? It should be in series with this. After that, this current will move through this 10 ohm towards D. So in this 10 and 10 are series 20. This 10 and 10 are in series 20. 20 and 20 again 10. So we are getting this resistance 10. So what finally we are getting? 10 plus 10 plus 10. Final answer is 30 ohms. 30 ohms. So we are going with A. Next, 27th problem. The current in the following circuit is, see, when current is coming, it is dividing in two parts. I1 is in this branch, I2 is in this branch. Means both branches are parallel, but same current will flow through this 3 and this 3. So these are in series, 3, 3, 6. This 6 in parallel with this 3. So total resistance should be 6 into 3 upon 6 plus 3, means 18 upon 9, 2 ohm. And battery is of 2 volt. So I should be V by R. 2 by 2 means 1 ampere. So we are going with B. Next, the current in given circuit is, only values are changed. 6 and 6, 12. 12 and 3, total resistance is 12 into 3 upon 12 plus 3. 36 by 15. 2.4 ohms. Total resistance is 2.4 ohm. So I should be, I is V upon R. So I should be V by R. V is 4.8 volt, resistance is 2.4. So we are getting 2 ampere, so going with D. Next, the net resistance of the circuit between A and B is, see, Wheatstone bridge principle is applicable. Ratio of 3 and 4 and 6 and 8 is same. Since 3 upon 4 is equals to 6 upon 8, so current will not flow through this. So it is out of circuit. What current is flowing through 3? Same will go through this. So 3 and 4 that are in series. What current is flowing in this 6? Same will go through 8. So 6 and 8, 14. It is B and here it is A. So now 7 and 14 are in parallel. So final resistance should be 7 into 14 upon 7 plus 14. 7 3s are. So we are getting 14 by 3 ohms. So we are going with B. Next, from 2004, resistance N, each of R ohm when connected in parallel give an equivalent resistance of R. It means R should be small r by N. If these resistance were connected in series, the combination would have a resistance in series. It will be NR and value of R is NR. So we are getting N square R. So we are going with option A. 31st, it is from 2005 AIPMT. When a wire of uniform cross section, a length L and resistance R is bent into a complete circle, resistance between any two diametrically opposite points will be, they are saying resistance of whole wire is R and length of wire was L. we make a complete circle. It is diametrically opposite point A and B. We want to calculate total resistance between A and B. What will happen when current will approach from A to B? It will divide in two parts, one part through this branch, one part through this branch. Area of cross section is same if resistance of initial wire, whole wire was R. So now half part is in upper portion, half part is in lower portion. So its resistance should be R by 2 and it's also R by 2, because R is proportional to L. Now these two parts are in parallel. So total resistance if is R dash, 1 upon R dash is 2 by R plus 2 by R, 4 by R. So R dash should be equal to R by 4. So total resistance is now R by 4. Next, it is from 2008 AIPMT. In the circuit shown, the current through the 4 ohm resistor is 1 ampere. They are saying current in this branch is 1 ampere. When the points PM and M are connected to a DC voltage source, the potential difference between the points M and N is, we want to calculate this potential difference. How to solve this? This resistance, one point is connected with M, second is N. So what potential difference we will got here? That is, it should be our answer. Getting my point? What potential difference is at this branch? It will be our answer. We want to calculate between N and M. So we will start from the resistance, for which we get two things. For 4 ohm resistance, you can calculate V, I into R. I is 1, R is 4. So it has voltage 4 volt. 3 ohm is parallel. So for this we should be 4 volt. So you can calculate current in this 3 ohm. I is equals to V by R. V is 4, resistance is 3, so it is 4 by 3 ampere. So it means potential difference in upper branch. I am saying this point Q. So potential difference in upper branch means PQM is equals to 4 volt. No need to calculate for this, it is 4 volt. So it should be 4 volt in this branch, in lower branch. Therefore, in lower branch, potential difference should be 4 volt. What is lower branch? Is made up of this 0.5 and 0.5 parallel. So 0.5 by 2 means 0.25. So one resistance, it is P, connected with P one end. It is 0.25. And it is 1 ohm. It is N. And at this side M is there. So total potential difference is in this branch should be 4 volt. Same current is passing through both. So voltage will be divided in the ratio of what is I? From formula, if voltage in this is V1, in voltage in this is V2. Current through this is V1 by 0.25. Current through next, it should be V2 by 1. Both should be equal because they are in series. So what we are getting, 0.25 means 1 by 4. So we are getting V2 is equals to 4V1. But V1 plus V2 is 4 volt. So V2 means 4V1. So 5V1 is 4. So V1 is 4 by 5. So therefore V2 should be 4V1. 4 into 4 by 5. So what we are getting? 16 by 5. V2 is 16 by 5. 16 by 5 means 3.2. So we are going with option B because V2 means 16 by 5, 5 3s are 15, 5 2s are 10. So we are going with 3.2 volt, we got 32B. 33. A wire of resistance 12 ohm per meter is bent to form a complete circle of radius 10 centimeter. They are saying radius is 10 centimeter. Resistance between its two diametrically opposite points. Just we saw in a previous problem. What will happen if we will calculate the total resistance of wire? If you know the total resistance of wire, total circumference is 2 pi r. Wire's total length is 2 pi r. R is 10 centimeter, means 0.1 meter. So it is 0.2 pi. So resistance of whole wire should be 0.2 pi into per meter resistance is 12 ohms. So we are getting 12 into 2, 2.4 pi ohms. Just we saw in previous problem this. If you bend the wire in form of circle, the net resistance between diametrically opposite points should be R by 4 if it is initially R. So now resistance should be R by 4, means 2.4 by 4 pi ohms, means 0.6 pi ohms. So we are going with D. 33rd D. So now we are going to solve this. The internal resistance of a cell is 2 volt, is 0.1 ohm connected to a resistance of 3.9 ohm. The voltage across the cell will be, first we will find current across passing through the, means what current we are taking from the cell. Formula you know, E upon R plus R. So it should be 2 upon 3.9, it is not 39, it is 3.9 plus 0.1. So what we are getting? 2 by 4. It is 2 by 4 means 1 by 2. Current is 1 by 2 means 0.5. 3.9 plus 0.1. So now what is the potential difference across the plates of cell? We know that that is E minus I into R. What is E? 2. What is I? 1 by 2. What was R? 0.1. So it is 2 minus 0.05. It means 1.95 volt. So we are going with A option. 35th, it is from 2000 AIPMT. Car battery of EMF 12 volt and internal resistance 5 into 10 to the power minus 2 ohm receives a current of 60 ampere from external source. Then terminal potential difference of battery is, it means already it was 12 volt. We are getting current from external source. It will also give it potential difference. So net potential difference should be 12 plus 60 into I into R, internal resistance, 5 into 10 to the power minus 2 ohm. So now it will be 5 into 630, 300 into 10 to the power minus 2. Remove this minus 2. So what we are getting? It will become 15 volt. 36 from 2000 to AIPMT. For a cell, terminal potential difference is 2.2 volt when circuit is open, means E is given 2.2 volt, and reduces to 1.8 volt, means V is given when resistance of 5 ohm is connected. What should be R? Direct we have formula, capital R E by V minus 1. We have derivation in theory part. What is R? 5. What is E? 2.2 divided by 1.8 minus 1. So it is 5 into 2.2 minus 1.8, 0.4 divided by 1.8. Remove this decimal. So in numerator we are getting 20 by 18, means 10 by 9. So we are going with A. So A option should be correct. So we are going with A. Next, a student measure the terminal potential difference V, EMF E, internal resistance R as a function of current. The slope and intercept of the graph between V and I is. It is a graph between V and I. We know that what the graph will give you, slope will give you resistance. Slope will give you resistance. Since graph has a negative slope, because if this angle is theta, what you are getting tan theta? Negative. Tan theta we are getting negative. Slope is negative, it means y should be in this format, line should be in this format. Y is equals to C minus mx. So internal resistance should be negative, and negative is given in two options, but they are using respectively. So only in one option we are getting this minus R, this. And intercept will give you maximum value of V, means EMF, this. Next, in 2006 AIPMT, two cells having the same EMF are connected in series through an external resistance R. Cells have internal resistances R1 and R2. When the circuit is closed, the potential difference across the first cell is 0. The value of R is, what they are saying, two cells having the same EMF are connected in series. Are connected in series. It is E1, it is E2. Through a resistance of capital R. Through a resistance of capital R. What should be the value of current? E plus E. Both have EMF same. Means if E1 is E, E2 should be E. So current is 2E upon R plus R1 plus R2. But what they are saying, potential difference across first cell is 0. But potential difference should be E minus I into R1. So it is 0. It means E minus 2E upon R plus R1 plus R2 into R1 is 0. Divide whole equation by E. So what we are getting? R plus R1 plus R2 is equals to 2R1. So what is the value of R? R should be R1 minus R2. So we are going with B. 39th, from 1989 AIPMT, current of 2 ampere passing through a conductor produces 80 joule of heat in 10 seconds. The resistance should be, we know that what is heat? Heat energy is given by I square RT in joules. They are saying 80 joule. Current is 2 ampere. Resistance we want to calculate. Time is 10 seconds. 80 divided by 40 means 2 ohms. So B should be, answer should be B. 40. Two identical batteries, each of EMF 2 volt, internal resistance 1 ohm, are available to produce heat in an external resistance by passing a current through it. The maximum power that can be developed across R using these batteries is, we know that for maximum power, R external should be equal to R internal. Now two cases arises. When batteries are connected in series or they are connected in parallel. First case I am taking A, when batteries are in series. What is their internal resistance? 1 ohm and 1 ohm, 2 ohm. So R should be 2 ohms. R external should be 2 ohms because internal is this. So what current I we will get? I is equals to E, 2 volt and 2 volt, 4 volt upon capital R plus small r, 2 plus 2. So we are getting 1 ampere. So power is V into I. I is 2 ohm. So what we are getting? So what we are getting power? Power is V into I. V is 2 volt and I is 1 ampere. What we are getting power? Current is 1 ampere and we know that power we can calculate in so many ways. R is 2 ohm, power is I square R. I is 1, 1 square is 1 into 2 is equals to 2 watt. If they are in parallel, total EMF will be equal to EMF of one cell, 2 volt. Total internal resistance, now they are in parallel. So 1 into 1 upon 1 plus 1, it should be 1 by 2 ohm. So R external should be 1 by 2 ohm. So current now in circuit, E by R, 1 by 2 plus 1 by 2, it is 2 by 1 means 2 ampere. So power developed is I square R. I square means 2 into 2, 4 and resistance external is 1 by 2 in this case. So again we are getting 2 watt. In both cases we are getting maximum power 2 watt. Next, two batteries of EMF 4 volt and 8 volt, they are in opposing each other. Internal resistance is given, external is given. So current we can calculate very easily. I, net EMF is opposing each other, so it is 4 volt. Total resistance 1, 2, 3 and 9, 12. So what we are getting? 1 by 3 ampere. Only in one option current is 1 by 3 ampere. So we are going with A. Kirchhoff's first law. What is Kirchhoff's first law? It is conservation of charge, and second law, conservation of energy. 43rd, in a meter bridge, the balancing length from the left hand is found to be 20 centimeter. R is 1 ohm. I gave you formula for meter bridge. What was the formula? S is equals to R into L upon 100 minus L. R is given 1 ohm. Balancing point 20, 100 minus 20 is 80. So what we are getting? 1 by 4 means 0.25 ohm. So we are going with D. 44. A potentiometer consists of a wire of length 4 meter, resistance 10 ohm, connected with 2 volt battery. The potential difference per unit length. Potentiometer is of EMF 2 volt. Wire of length 4 meter and its resistance is 10 ohm. Means potentiometer will apply a potential difference of 2 volt across the 4 meter length. So potential gradient means V by L, 2 volt across 4 meters. So it should be 0.5 volt per meter. So we are going with A. 45th, from 2001 AIPMT, specific resistance of a potentiometer wire is 10 to the power minus 7 ohm. Current flowing through it is 0.1 ampere. Cross-sectional area of wire is 10 to the power minus 6 meter square. What is potential gradient? Potential gradient is V by L. But V is not given. But Ohm's law, V is IR. What is R? Rho L upon A. Cancel L with L. Everything is given. Current is 0.1 ampere. Specific resistance 10 to the power minus 7 ohm meter. All SI units. Area of cross section 10 to the power minus 6. So what we are getting? 0.1 into 10 to the power minus 1 volt per meter. Means 10 to the power, we can write it 10 to the power minus 1 minus 2 volt per meter. So we are going with A option. So in this way, we have completed our 10th unit of crash course, which was current electricity. Thank you.